Okay, so I'm going to do some trig identity problems. Okay, this is from worksheet number 1. This is problem number 1. If you have secant x times cosine x, okay, these are reciprocals. Boom. Secant x and cosine x are reciprocals. So, like we mentioned in part 1, if you have that, they're equal to 1. When you multiply reciprocals, they're equal to 1. Okay, number 2. You have tan x over sine x. Okay, this is a pretty straightforward problem, but just so I'm being clear, we're going to use technique number 1. We're substituting sine and cosine x. Okay, I think there's a more technical name for this. Okay, and another issue that comes up here is that you've got sine over cosine over sine. I would get in the habit of sine x over cosine x times 1 over sine x. Okay? Just if you have something down here, I would just write it as a fraction, 1 over sine x. Okay? These signs will cross out and you get 1 over cosine x, and then if you apply the reciprocal, you get secant x, and you've simplified it. Okay. Let's move on here to, let's see if we can find something. 3 and 4 are just reciprocals. They're both going to end up being equal to 1. So let's move on to number 5. If you're following along, you'll know what I'm talking about if you're following along with this worksheet number 1. Okay. Let's see here. Sine squared x, this is number 5, plus cosine squared x, all over cosine squared x. Okay? When I look at this and I analyze it, I'm looking for a couple different things. Again, I've only got 5 techniques. The fact that these things are squared means it's probably a Pythagorean identity. Most of the time. Pythagorean theorem is a squared plus b squared. And this is a pretty easy one. Sine squared plus cosine squared is obviously 1 over cosine squared x. And then we do the reciprocal, which is going to be secant squared x. Remember, chicken salad. Do we want to do 6? Okay, 6. We have 1 minus sine squared x times 1 plus secant squared x. Okay? Now, if I look at my Pythagorean identities, one of these is going to be able to be substituted and one isn't. By the way, we're going to be using technique number 2 here. And I'm suspicious because I've got these things that are squared at points to Pythagorean theorem. Okay, so if I take 1, if I subtract sine squared from both sides, I'd get 1 minus sine squared, and that's equal to cosine squared. But secant squared, if I subtract 1, it would be secant squared x minus 1. That's not what I have in this problem. I've got secant squared plus 1. So 1 minus sine squared is the only substitution I can do. And this becomes cosine squared x times 1 plus secant squared x. If you're wondering where I'm coming up with this, you're going to have to just on your own take sine squared x plus cosine squared x equals 1 and add and subtract some things over. What you'll find, if I subtract sine squared x, cosine squared x is equal to 1 minus sine squared x, and then I can do the substitution. Okay, since I can't do a substitution here, I'm going to basically do the distributive property. Algebra 1 stuff. The trig is over. I distribute and I get cosine squared x. And what's cosine squared x times secant squared x? Well, chicken salad, they're reciprocals, so it's equal to 1. And I'm done. That's as simplified as that's going to get. Okay, what's another good problem to go over? Okay, so let's go over 7. Okay, again, this video is not to do every problem, it's to help you with the analysis of this. These are conjugates. I know that when I multiply conjugates, I get a difference of squares. Okay, so I'm going to multiply these conjugates and I get secant squared x minus 1. Well, this now starts to remind me of the Pythagorean identity. And sure enough, if I subtract 1 from both sides, I'd get a secant squared x minus 1, and then be left equal to the leftover tan squared x. So here I'm going to do a trig identity substitution, and I'm going to get tan squared x. So again, multiplying conjugates to get a difference of squares, but that difference of squares allows me to do a Pythagorean identity substitution. All the same techniques. Okay, let's see if we can find something else. Let's do 8. Switch pens here. Okay, what's going on here is we're going to need to factor this. I've got a greatest common factor, sine squared x, in both of these. So I'm going to factor out a sine squared x. So left over in the first term is secant squared x minus 1. And here's our same exact substitution we had on number 7. So first I get a greatest common factor, and then I've got a Pythagorean identity substitution. These are all basically, if you look at your techniques, number 4 I factored, and then number 2 I did a Pythagorean identity. The point of this video is to show you that there's only 5 things you're really ever doing. Give or take a couple minor things here and there. Now basically a tangent is sine squared over cosine squared. And so the only thing I can do here is maybe multiply this and get sine to the 4th x over cosine squared x. Okay? I would maybe even just leave it as sine squared times tangent squared. That to me seems more simplified than the other one. And that's what was on your answer sheet as well. Okay, let's just skip down to number 10. So we can do a common denominator one. Okay, the reason I know I need a common denominator is because I'm subtracting 2 fractions. Common denominator, number 5. Okay, so the common denominator, these are also conjugates. So I know that when I do the common denominator, I'm going to get a difference of squares. This is the level of analysis you should be able to do prior to the problem. If you're going to write out all the steps, it's going to be a lot more work. Okay? And let me demonstrate that. I've got a secant x plus 1. I know I need a secant x minus 1 on top and bottom. Minus 1 over secant x minus 1. And then over here I need a secant x plus 1 on the top and the bottom. Okay? That's what's happening. I would have skipped this step and gone right to the next step. I'd recognize these are conjugates. I know when I multiply them together I get secant squared x minus 1. And on the top I would get, this is missing the secant x minus 1 minus parentheses the secant x plus 1. Okay? The rest is just simplification. Secant x minus 1 minus secant x minus 1. I just distributed the negative 1 all over secant squared x minus 1. Which these cross out. I get a negative 2. And I'm going to do a Pythagorean identity substitution, and this becomes tan squared x. What's the reciprocal of tan squared? Cotangent squared x. So it's negative 2 cotangent squared x. Okay, this is a 10-minute video. That's long. The point of the video, again, is to show you that you're really just using these 5 techniques right here that we went over. And this is to give you a short list of things to just check. Maybe I can try this, maybe I can try this. Okay? I hope this helps. Bye.